Hi, Chris Kuzmal here. Today we're going to be implementing the delete operation for linked lists. We have two test functions, line 22 and line 23 here, test delete 1 and test delete 2, which are implemented in the standard way. They return true when we have a pass and false when they fail. Let's take a quick look at test delete 1. Test delete 1 creates a linked list and then puts in an element which has a key of value 3 and another element of key of value 4. The name of the local variables representing those elements are FE and SE, respectively. We then actually do the insert operations into the linked list named FL. So we do FL of FE and FL of SE. And then we do a delete operation, FL dot delete FE. And that should make it the case that therefore if we do a search into the list looking for the key 3, well, FE is the item that had the key 3, so that should turn out null. That's not necessarily satisfying though, because although, certainly if it's not found, then that suggests it's been deleted, but we'd also like to verify that it is still there when we delete something else. And so delete 2 does the exact same sequence of operations, except the delete operation is on SE instead of FE. And so when we search for key 3, we would expect to find FE successfully. And of course, if you look over here, you see we passed all 7 of our tests, and these 2 are 2 additional tests before we had 5 tests. Okay, that's lovely. What does the code look like? The code looks like if we go into linked list, we go and we have the delete method. All right, the delete method takes an element as an argument, and it checks to see whether or not that element has a previous value, which is not null. If the previous value is not null, then what we need to do is get that previous value. That's what this portion of code does. The highlighted, that gets the previous element and then sets that previous element's next value to be the next value of the thing we're deleting. So the thing is deleted and its next value is passed on to its previous value. That's what happens if there is a previous value. But if there's no previous value, then we're simply going to assume that the head of the list needs to get the next element from A, because we're assuming A is at the head of the list. Okay, and A's next element needs to replace A. If, on the other hand, in addition, if the next element after A exists, then we need to get that element and set its previous value to what the previous value for the element that's being deleted was. So we have an element, we're getting rid of it, we take its previous element, and we set its next element's previous value to its previous element. And that's what happens there on line 26. That all needs to be checked. One of the things that happened when I was looking and thinking about this was I got a little bit confused on this. I was checking the search, and it seemed like search would never return null. Because like, what if we search for something that's not there? Because when you delete something and you search for it, what's the behavior? And we hadn't really checked that out. And at first glance, when I looked at the Corman-Liserson and Rivest code, it seemed like it was returning the head. As if nothing happened in this loop, then it would return the head, and that would not be null. But it turns out that the only occasion when that loop does not proceed is when the head is not null. That is to say, if the head, so if the head is null, the loop doesn't proceed, and it does return null. If the head is null, then it's going to proceed until X is null. And so I thought that the search had a bug in it. I was all excited. I was going to email Liserson or maybe Corman or Rivest, if they're all. I'm not sure Mr. Rivest is still around these days. No ill intent there. I just took a class from him 35 years ago, so who knows if he's still around. I know Charles is still around. In any case, it all works. 2 more tests. We now have a linked list that does delete.